Good morning, everyone. This video is all about an overview of metabolism, which we talked about a little bit on the first enzyme video. And then we're going to do an overview of aerobic respiration. And that's where this little foldable is going to come into play if you choose to use it. Okay, so the first slide is just review, so it has nothing to do with the foldable. But the second slide is all about aerobic respiration. And all the information is going to go on this top little flap here. Sorry, time for his breakfast. Okay, so you may want to listen to the slide and see what's going to go on here, and then copy it onto this top region. Okay, this slide is going to have, animations and kind of things that like words at tilted angles just to make it kind of fun. But when I usually do this in class, I just list a lot of the information as bullet points over here, and then I do like the pictures and stuff kind of stacked over on the right. Okay, so let's go ahead and get through this. So let me stop sharing my video and start sharing my screen. There we go. Okay, so as a reminder, metabolism is all the reactions in a cell. Okay, but we can divide those types of reactions into two categories: anabolism, which represents the anabolic reactions, and catabolism, or the catabolic reactions. Okay, so just as a reminder, with anabolism, we're taking smaller molecules, putting in energy in order to build a larger, more complex molecule. Okay, so we're building things, and this requires an input of energy. Catabolism is just the opposite. It's where we're taking larger molecules, maybe like a large sugar molecule, and breaking it into smaller pieces as a way to release energy. This is what happens when we eat, right? We can break down some of our energy reserves in order to release energy, so we don't faint every time we eat. Okay, so now I know this is in the context of microbes, right? And we're mainly talking about bacteria, but eukaryotes do this as well. Okay, all right, so two new terms to introduce to you. The first being endergonic. So an endergonic reaction is when you are putting in energy to build something. So anabolic and endergonic go hand in hand, but with endergonic, we're typically talking about the input of energy, what we're really focusing on. And so then with catabolic reactions, if we're looking at the release of energy, we call that exergonic. Okay, so I think of ender sounds a lot like enter, right? So energy enters the reaction during an endergonic. Energy exits the reaction on the right, so it's exergonic, so it's like exiting. So it sounds like entering the reaction and exiting the reaction. Okay, so this next slide, this is the content you're going to want to put on that top flap of your foldable if you're using that approach to take your notes. So the first term you want to write down is catabolic. Respiration is all about breaking down glucose and other molecules in order to release energy, but that energy is actually going to be harvested so that the cell can make a ton of ATP. Okay, but in order to do that, we have to break down molecules in the cell. So it's a catabolic process. Notice it's called aerobic. Aerobic means it requires oxygen. Okay, so aerobic respiration is made up of three big steps. And most of these steps require oxygen in order to occur. And then the last just little definition here, well, for now, is exergonic, because again, a lot of these reactions, we're going to be releasing and harvesting energy throughout this process. So it is an exergonic process. And remember, y'all, catabolic and exergonic are typically associated with each other. So as a quick reminder, right, you always want to know, where do these processes occur in the cell? Well, when we talked about eukaryotes, we talked about the mitochondria is where respiration occurs. So we've talked about two of these parts of the mitochondria. We have this smooth outer membrane, But then we have this folded inner membrane, which we call cristae, but you can also write down inner membrane. You'll be hearing that phrase too. But we're also going to be talking about reactions that happen in this middle region, okay, this space within the inner membrane, and that's called the matrix, okay, the mitochondrial matrix. Now, of course, organelles are only found in which type of cell? Eukaryotes, right? So what about our prokaryotes? Where's all this going to happen if they don't even have a mitochondria? Well, most of these steps are going to happen in the cytoplasm, okay? But one of the steps, the final step, is going to happen in the plasma membrane. But we're going to break down the location where each step occurs later. But the bulk of this process for prokaryotes will happen in the cytoplasm. Now let's remind ourselves, why in eukaryotes, why does this inner membrane, why is it all folded? Why does it have cristae? Well, remember, it needs to maximize surface area, because it turns out the enzyme responsible for making ATP, which is the goal of respiration, make as much ATP as possible. The enzyme responsible for making ATP is found in that inner membrane, in the cristae. And so the more cristae we have, the more ATP making enzyme we have, the more ATP the cell can make, okay? So that folded inner membrane is that way so that we can maximize surface area. All right, some new ideas are electron carriers, okay? So energy is stored in the bonds of molecules, okay? Remember, bonds are formed when two molecules are sharing electrons, okay? So as we break down molecules to harvest their energy, we're going to be breaking those bonds and kind of snagging those electrons. We're storing, or we're holding on to those energetic electrons, okay? So two electron carriers in this process are NAD+ and FAD. And I think of them as little taxi cabs, because they're just in this form, they're just chilling, they're quote unquote empty, but they can carry two electrons to different parts of the cell. And so they can each hold two electrons, okay? And when they do, they are called NADH and FADH2. Okay, so when you're looking at it written out, we're essentially following the hydrogens, right? Because don't we agree that whenever we have a single electron, it's normally, right, associated with a single proton, right? Balance out those charges. And so with NAD+, if it's acquired two negatively charged electrons, right, the first negatively charged electron cancels out that positive charge with NAD+. Then the second electron would be associated with a single hydrogen atom, right? So it's got NADH. And then with FAD, if it carries two electrons, it's going to also need to snag two hydrogen protons to balance out those charges. So we have FADH2. Okay, so each of them carry two electrons. Now, we do have some names for these terms and for what we're going to categorize other reactions in this process as, and that is redox reactions, okay? And so redox is actually merging two words together, and that is reduction and oxidation. And we merge the name of those reaction types because they always go hand in hand. Whenever there's a reduction, there's always an oxidation. Okay, they always go hand in hand because look at those definitions. Okay, reduction is gaining an electron and oxidation is the loss of electrons. Okay, and so whenever something loses an electron, something else had better be there to gain it, right? We don't want these negatively charged electrons just causing chaos in our cell, right? So whenever something loses an electron, another molecule is going to gain it. Now, something I didn't put on this slide, which was purely by accident, is the words oil rig. So I would definitely add that to your foldable or your notes. Oil rig. And so this is a helpful way to remember the definition of oxidation and loss, because for oil, the OIL is for oxidation is loss, and then RIG, R-I-G, reduction is gain. So it's a way to help you remember which one is an oxidation reaction and which one is a loss of electrons. So again, oxidation is loss of electrons. Reduction is gaining of electrons. Okay, so oil, RIG. I still say it whenever I teach this, or I say it in my brain to keep them straight. Okay, so let's do a visual of this real quick. So here's our little empty electron carriers. They're just chilling, looking for some passengers. And then when they pick up 2 electrons, okay, here's just a model of what's happening. Those light blue circles are my electrons. They have now gained electrons. So NADH and FADH2 are said to be reduced because they've just gained 2 electrons. But what these electron carriers are going to do is drop off these 2 electrons at another part of the cell. That we'll talk about those details later. So essentially this arrow here with the 2 electrons goes both ways, because these electron carriers, NADH and FADH2, are going to drop off their electrons. And so once they've dropped them off, they've essentially lost their electrons. So we say NAD plus and FAD are oxidized, okay? So this is just a very brief overview of respiration, and we're actually going to get into the individual steps of respiration in the following video. Let me know if y'all have any questions.